You thought it was a turret, didn't you?
Missile.
So my dean can say, Tech, wake up, you're sleeping on your job. Paintball.
No eating in class, shoot the sandwich. Paintball, you're not going to want that sandwich anymore. Unless you're really hungry. But
All right, well, the recording has started. Well, since you guys talked about paintball and turrets, paintball century.
Oh god.
That thing is impossible to get away from.
Yeah,
Once it locks on you,
it shot a basketball bouncing.
yeah. It leads you.
it knows how to lead the target. It's on its feet.
Well, it has to do with the rate of fire as well.
Oh my.
This guy doesn't stand a chance.
I don't know,
That's
that
why he's-
shield is pretty impressive.
Like, once he passes trees, it's crazy.
Fix it.
You should see the camera on it. It's so sick.
That'd be pretty cool. I'd give me that.
Well, that's a better one.
So hard.
This is a really good one, because you would think a person is pretty big and should be able to get a person, right? This is.
There's one beer left on.
Joe is thirsty.
So thirsty. He's gonna leave a thirsty, worst drinking game. Having to get
Oh, that's the
back.
motion sensor.
So it's slow motion.
It hit the laptop.
Maybe next time I'll have those.
Multiple hits. That's
Maybe
what
or
it says.
it just keeps hitting you when you're on the ground.
No, if you don't move, I don't think it hits.
Yeah, it stops the sensor.
Yeah.
Yeah, that one detects motion.
Yeah, it detects not just the motion, but also where the motion is relative to the camera. But it's predictive as well, and that's why it can track the target.
I think the last one they set it to the color red.
Board it out.
Maybe if you want slow
You ain't getting this. You ain't getting
Hit. Yep. I think this guy is going to be hired to work on the next, is it called the failings? But there's one that has a basketball. I'm trying to look for the one that has a basketball because that one is actually quite amazing. Tony Stark.
Bring one of those paintballing. They're pretty cool. Get it to run on a Raspberry Pi.
This is running on a laptop, and I'm pretty sure you can run it on a Raspberry Pi. Also
You could just be attached to the paintball gun.
integrated.
Give it a 360
Have it on your,
sensor with friendly ID tags. If it
Have it on your back.
that they are
Have it on,
relatively
on your
close.
backpack as defense.
On my backpack.
Diversionary tag. Just grab a handful of bounce.
Oh, here's the basketball. It shot the ball first, and then it moved on to him. Oh, hits multiple hits again. He threw a tennis ball to try to confuse the turret, right? And it cannot be a person. I don't think a person can aim as well as this turret.
Not in this program, correct?
I mean, just look at how fast it was able to sweep all the way back.
Yeah,
It
only
shot the
part
ball
where-
first and then back to him. It's like, okay, we got enough time.
Yeah, the only part with humans where that changes that if something's so obvious we know not to shoot the basketball. That's all. That's where.
But
we
if
have
you
to
can,
learn.
why not, right?
Exactly. And then afterwards, like that.
And the question is, if you can, why not? Shoot them both.
It's worth extra points.
Yep. Yeah, so I'm pretty sure this guy is going to get hired by Raytheon to work on the, is it called the Phalanx? it's a weapon to shoot down incoming projectiles on destroyers.
Oh yeah.
Yeah. So those things are interesting
It's
too.
called Sea-Whiz. They already have that.
Hmm?
On the carriers, they already have that. It's called Sea-Whiz.
If we can
Yeah, it's called a phalanx. And if you look for videos, it's really quite interesting. I mean, these things. This is the land version of it. They have land and sea versions of those things.
That's what's there.
You can hear the sound.
Those things are ridiculously loud. The rate of fire is something.
I believe it's 7,200 rounds per minute.
Yeah,
Wow.
they have them, stationed in
Or
front of
the-
the carriers,
Mm-hmm.
and when they run ops on them, it shakes the entire side of the ship. It sounds like 9 chainsaws going on at the same time. It's ridiculous.
Oh.
It's okay, it's just black steam.
Yep. It shot that. See, it shot the target. It's probably a bomb.
Yeah.
That's actually a bomb. It's basically falling using gravity, and then the gun was able to track it and basically disintegrate the bomb while it's in midair.
Terror.
Yeah, these things they run on it's called what they call a Gatling gun, and same type of Gatling gun on jet fighters, except this thing has a lot more rounds, right? On an airplane, you can. I think the ammunition on a fighter plane cannot sustain even close to a minute. If you just hold down the button, in less than a minute you'll be out of rounds.
Yeah.
But these things, have a lot more, because they're not restricted. You're not restricted by how much payload you have, on the warship. Well, there's
not
restriction,
nearly.
but a lot
Not
more. Yeah. But I just thought, the auto sentry, using a paintball gun, was able to do, about the same thing, but using paintball. That's just kind of a little excessive. I will just kind of going through this stuff here. There are states already trying to make laws or legislature to outlaw driving while wearing Google Glass. So if someone sees you with a Google Glass and you're driving, the police can stop you and give you a ticket, just like when you're driving and talking on the phone at the same time.
Hands-free.
Just the other day, I didn't put it up here. Just the other day, like yesterday or day before yesterday, some woman in San Francisco was wearing a Google Glass in a bar, and got into a argument with somebody else, and then the whole thing was recorded. And the argument was, because of privacy, the other party said, I don't want you to be recording this, and then the response was, guess what? This is also getting recorded. So that really did not help in terms of, getting out of that confrontational situation.
Isn't recording video without them knowing legal?
It is.
I don't know. Is it legal?
Photographers can take pictures of celebrities.
Yes, First Amendment. You
Yeah.
can record
Then why do we have release forms?
They can't sell.
Oh, okay. So the key is whether they can sell it or not, but you can.
gain of someone else's image.
Okay, I see.
That's photographers.
Yeah, but there are issues like if you walk into a bathroom with Google Glass, then what kind of law would apply in that case?
Stalking, being creepy.
Uh-huh. But you can claim the device is off, right? You can just turn it off before going to the bathroom. We'll just make sure that when you walk into a bathroom, there's like a big magnetic coil, right? It will just zap every electronic device on you. You better leave everything outside of the bathroom. Otherwise, as you walk through, you can hear your cell phone, the Google Glass, all buzzing at the same time. And then once you get past that point, smoke will come out of the electronic devices. It's like, oh, forgot.
Then your face is on fire.
Well, that's only if you have your tinfoil hat. Okay, if you don't wear a tinfoil hat, you will still be okay. It's like walking into a microwave oven with a tinfoil hat. Not a good idea. All right. All right. So what we'll do today is we'll go over the answer of the nested statement homework assignment first.
Uh-oh.
So we'll go over that first, and then we'll start on the next homework assignment, which is based on pre and post conditions. All right. All right, so we'll start with this one. And let's see how many questions we get here with the trace of this one. So we have comments, line number, and then the two variables that we have, which is x and z. We'll go ahead and change the column size and then just magnify so that you guys can see it more easily. The precondition is we do not know anything about z or x. Because even if you knew anything about these two variables, line 1 and line 2 will basically overwrite the initial values anyway before we make use of x and z in the loop. So that means you might as well just say we didn't know anything about x or z. In the homework assignment, I also did not make any assumptions. There's no instruction to say assume x has a value of blah blah blah. So that means we really should use question marks in this case to basically say x and z have unknown values to begin with. On line 1, x gets initialized to 0. On line 2, z gets initialized to 0. On line 3, we evaluate the condition of the loop. Z is less than 5 is true. We move on to line 4. X is greater than or equal to 2 is or false. So where do we go?
Line 7.
Line 7? Yep, line 7 is the else branch of the conditional statement on line 4. So we skip all the way to line 7 in this case. Line 7 is adding 1 to z. Z goes from 0 to 1. Then we move on to line 8. Line 8 checks to see whether x is greater than 1. And is that true or false? It's false. Then we move on to where?
12.
Line 12. Very good. Are there any questions about why we are moving on to line 12 in this case? No questions? Okay. All right. Well, that's not the this class is a little bit different from my other class. In the other class, there were quite a few questions about why we're moving on to line 12, and that's why I kind of paused and see if you guys want to talk about it. Yep.
Why did we move to line 12?
Why did we move on to line 12? Okay. So we're moving on to line 12, because I'm assuming your question is genuine. So we are moving on to line 12 from line 8 because line 8 is false. Okay. The conditional statement from line 8 to line 10 does not specify what to do when the condition is false, which means there's nothing to do when the condition is false. It's the same thing of having an else part, but the else part is empty. There's nothing there. So that means when the condition is false on line 8, we are done with the conditional statement from line 8 to line 10. But this conditional statement also turns out to be the last statement of the else branch of the outer conditional statement. In other words, if you look at line 7 all the way down to line 11 as one single, if you look at line 7 to line 10 as one single block, this is the end of that block, which is the end of the else block of the conditional statement started on line 4. When we are done with one branch of a conditional statement, we continue with whatever is after the conditional statement. So that's why we are moving on to line 12, which is the statement after the conditional statement, starting on line 12 and ending on line 11. Yep.
For the homework, if we didn't show lines 3 and 4 in the comments, like we just left it out completely, is that wrong?
That would be wrong because I need to know why you choose to get into line 7 and 8.
Okay.
And also, when you are actually running this program in a computer, it would have gone through line, it would have gone through all these lines that we are already indicating.
What if we left in all the lines in between there?
All the lines in between, like from line 8, and then we have.
If it's all correct, but you just I left in all the lines, 9, 10, 11, and 12.
Line 10 and. Well, line 9 would be incorrect because if the condition is false for a conditional statement.
I didn't add any numbers or anything. I just kept the lines, so that's incorrect.
That would do it. It's incorrect because in a trace we only indicate the line numbers of the lines that we actually do something about. and we do not get onto line 9. Line 10 is an end if. Its only job is to mark the end of a conditional statement, of the inner conditional statement. And then line 11, its only job is to end the outer conditional statement starting on line 4. So we don't really trace those lines. But just for this homework assignment, if you trace line 11 before line 12, I'm still going to count it as okay, but only for this time, because in the future we do not want to trace the end if, the end while, or the repeat line of a loop. Okay. On line 12, we incremented the value of x to 1, and then where did we go?
3.
Back to line 3. Yep, that's right. So line 3 is checking z again. Z is less than 5 is true. Z has a value of 1 at this point. Then we go back to line 4. X is greater than or equal to 2 is false. Then we move on to line 7. And I'm going to do this trick here so that I can keep track of the header portion of each column, but I can scroll the rest independently. So on line 7, we are adding 1 to z, and I have to refer to the old value of z. Z was 1 already, now it's 2. And then we move on to line 8. X is greater than 1 is false. So we move on to line 12 again. And this time we are going to increment x from 1 to 2. Go back to line 3. Z is less than 5 is true. Go back to line 4. X is greater than or equal to 2 is true this time. Okay, so now we are taking a different branch, with the outer conditional statement. We are taking the branch to line
4 or 5.
5. Okay, we are on line 4 right now, and the condition is true, so we move on to line 5. On line 5, we are adding 2 to z, so z goes all the way to 4, and then where do we go? We go to line 12. Line 12 is adding 1 to x. X gets incremented from 2 to 3. We go back to line 3 again. Z is less than 5 is true, but this is the last time it's going to be true. Not the last time we go back to line 3, but the last time the condition is true on line 3. Then we move on to line 4. Line 4 is x is greater than or equal to 2 is true. And then we move on to line 5. Line 5 is adding 2 to z. Z goes from 4 to 6. And then we are done with the conditional statement, the outer conditional statement. We continue execution on line 12. Line 12 is adding 1 to x. X goes from 3 to 4. Go back to line 3 one last time. Z is less than 5 is finally false because 6 is not less than 5. And then we're done. Go to post. So are there any questions about this trace? Any transition of the trace that you did not quite expect or want me to kind of explain again? Yep.
Yesterday when I asked you about that diagram I made, did you show us how we'd draw it out as a diagram?
How to draw this out as a diagram?
Like the wow.
Okay, sure. Okay, so for this one, it's going to look a little bit squished, because there's a lot of detail, and pictures are really kind of, it takes up a lot of space just to describe, the logic. So I'll start with line 9, which is the deepest portion of this entire thing. So line 9 is just, z gets z plus 1, but it is inside a conditional statement. So that means, this is just one branch of a conditional statement. Is that okay?
Mm-hmm.
Right. So we'll just go ahead and draw this conditional statement like that. Now the else part of this conditional statement has nothing because it is a conditional statement that has no else. Which if you want to, you can either draw a straight line here to merge it, or you can draw a block here that has nothing in it. Either way is fine. Okay. It simply means when the condition is false, we don't do a single thing. So then we label true, false. All right. This conditional statement is preceded by an assignment statement, which is z gets z plus 1. Okay, so we get z gets z plus 1 right before that. Is that okay? So that takes care of line 7 to line 10 in this picture. Line 7 to line 10 is the else branch of the outer conditional statement. So now I would draw this one as a part of the else branch, of another conditional statement. Okay. The then part of that conditional statement is just line 5 itself. So the alternative to this entire branch here is over here, which is just saying z gets z plus 2. Like that. Is that okay so far? Okay. So this takes care of, well, I'm gonna, do you want me to write the condition too, or just the structure?
Just the structure.
Just the structure. Okay. So now we have taken care of line 4 all the way to line 11. Now, after line 11, we have another assignment statement, which is x gets x plus 1. So after the merge here, we have x gets x plus 1 as one last thing to do at the end of the loop. Now, this entire thing is the body of the loop, of the while loop. I'm not going to write the line 1 and line 2 because those two are fairly obvious. So after this, we go all the way back to the very beginning of the loop. Like so. But right after this point, after the re-entry point here, okay, this is where we come in initially, we have now to make a decision whether to get out or not. So now we have an exit path for the entire while loop, and that exit path is labeled false, and this part is labeled true, and that's the while loop. And then before the while loop, we have the two assignment statements. So the way you look at this is, you look at this conditional statement. It's basically one statement, if you want to look at it that way. It is one single statement. And then this conditional statement is basically just one statement as well, or you can look at it as one single statement. So that's how things are really nested, having one statement completely contained within another statement. Is that okay? All right. All right. Any other questions? If you look at the picture, look at the pseudocode, look at the trace, are there any questions regarding the solution to this homework assignment? No questions? All right. If there are no questions about this, I'm going to show you the next homework assignment, and then we'll talk about what you need to do to get the next homework assignment done. I'll let you guys take the picture first. It is so handy these days. You can actually use a cell phone to take a picture. Do your cell phones have enough sensitivity to record my voice all the way from back there?
Yeah, never tried it.
Never tried it? Okay. I'll bet you it probably has the ability to do it. You can crank it up. You can crank up the gain to do it. Okay. Okay. Because I know some people use a smart pen, and they're sitting like in the middle of the classroom, and the smart pen was able to pick up my voice as well. And the problem with the smart pen is it also picks up the noise of writing. So you'll hear the smart pen like the scratchy sound when you're writing on a piece of paper as well. All right. So if there are no questions, we're going to move on and talk about the new homework assignment. That would be your first assignment regarding pre and post conditions. Are there any general questions about pre and post conditions before I take a look at the homework assignment? No questions? All right, so we'll go take a look at the homework assignment. This note here is not complete yet, so I will basically go through all the things that you need to know about this homework assignment just by hand today. All right, so this is your new homework assignment. We start with y gets k, x gets y plus j, and I'm not telling you what is k or what is j. The whole purpose is so that people do not accidentally think this is a trace homework assignment and trace it instead. So we don't want to trace anything in this homework assignment. We want to derive the post condition of line 4, given that the precondition of line 1 is just true. In other words, I don't know anything about the variables. So if I don't know a single thing about any variable, what can I possibly conclude after line 4? That is the question. Okay. So keep an eye on this one. It is already in your homework assignment. There's no need to copy this slide because it's actually your homework assignment. So what we'll do today is we'll go through a bunch of rules about what do we do with assignment statements. Okay. So how to derive the post condition of an assignment statement from its pre-condition. That is the answer. That's the question that we'll try to answer in today's lecture. All right. Any questions about this part here? Okay. If there are no questions, what I'll do is I will start with the what is an inverse function. Okay. Is everybody familiar with this notation, function f of independent variable x?
Yeah.
Okay. So if I define in this case f of x to be x plus 1, is there an inverse function? If so, what is it? Well, first of all, is it possible to reverse that operation? Yep, it is possible to reverse that operation. So how do you reverse adding 1 to something?
Minus 1.
You subtract 1 from that something, right? Okay. So in this class, because I'm using a text editor, I'm going to use f prime to indicate the inverse function. Don't tell your calculus professor that I'm using f prime, abusing the prime notation here to mean the inverse function, because they will have a hard time with this. But in this class, because I don't want to use f to the power of -1, which is the proper way of saying the inverse function, I'm just going to use this as a notation of the inverse function of f. So in this case, the inverse function is x minus 1. Now, how can I prove that it's intuitive, but can I actually prove that f prime in this case is the inverse function of f? Well, I can actually do it step by step, can't I? So I can apply f prime to f to x. Okay, so we want to find out whether this actually boils down back into x or not. Okay, and tell me again what is x? What is f of x? X plus 1. So now I can replace that with x plus 1. Is that part okay so far? I just took whatever is inside the parentheses and expanded according to my definition up here. Is that okay? So what is the effect of applying f prime to something? To apply f prime to something is just to subtract 1 from that something. Is that okay? So if I apply f prime to x plus 1 as a whole, that means I am just subtracting 1 from x plus 1 as a whole. Is that okay? Is that really just the same thing as x?
No.
It seems to make sense, but how do you prove it? I mean, right now the operators do not work out the way that we want it to work, right? Okay, so I'm going to go through this just to be kind of anal about proving. Okay, is that okay? To subtract 1 is to add -1. Okay, and addition has a particular property that comes in handy in this case. What property should I use? In other words, if I want to go from here to here, which property allows me to do that? It's the associative property. Yep, it's called the associative property of addition, which basically means if you have a chain of additions, the order of evaluating the additions does not matter. Okay? And once I have that, I can say this is x plus 0. Okay? And that would be which property of addition? The identity rule. Okay? The identity property, which means if you have a number, if you add the negation of that number, then the sum becomes 0. 0 is the identity. Okay? And if you add x to any to 0, you just get x back. So I have just concluded or just proven in this case that f prime is in fact the inverse function of f. Are we doing okay so far? Okay. But what exactly is an inverse function? An inverse function is quote unquote a way to is to find your way home, okay, so to speak. Yep.
Can you elaborate a little bit more on f prime?
F prime? F prime is just my notation of it's the inverse function of f. It's the undo of f. Okay, so let's take a look at what exactly is the meaning of a function and what is the meaning of an inverse function. If I start with a value of, let's say, 4, I apply function f to it, where does it go? What is the result of f of 4 according to this definition? It would be 5, right? 4 plus 1 is 5. So if I apply function f, 4 gets quote unquote mapped to a value of 5. That's not 0.5, this is just a destination point. Is that okay so far? What if I apply function f to 60? You'll bring it to 61. 61. Okay. 61 is over here, and so on. So when I go from 4 to 5, 60 to 61, I am using function f. It is a map from one value to another value. If that is the case, the inverse function is basically saying, if I start with the destination, can I trace my way all the way back to the point of origin? That is the question. In this case, it is possible. Because if I start with 5, I can apply f prime, or f to the power of -1, that's the proper way to denote an inverse function. I can trace my way all the way back to the point of origin. If I start with 61, I can apply the inverse function and go all the way back to the point of origin of 60. That is the function, that is the purpose of an inverse function, is if I start with the result of a particular function, can I reverse the operation and get back to the original value? Is that okay so far? Okay. But some functions cannot be reversed. Okay? Most functions that we use in this class are probably reversible, but some functions cannot be reversed. I'll give you one function that is really simple, but it is not reversible. F of x is 5. Okay. Is that really a function? Well, sure enough, it is a function. It maps every single value of x to a single point of 5. So that means if you look at that one, I can start with 3 over here. It gets mapped to 5. I can start with 61. It gets mapped to 5. I can start with 100. It gets mapped to 5. Is that working out so far? It maps every single possible value to a single point of 5. So now the question is it reversible? In other words, if I'm standing here and I say the result of the operation is 5, do I know how I got here in the first place? Not to a single point, because I can say anything can get to this point, so the point of origin can be any one of these particular values. So that means this is not reversible, because in order for the function to be reversible, I have to be able to get back to a single point, not just saying, oh, any one of these values can bring me here. Is that okay? Does everybody understand why some functions do not have an inverse? There's no way to reverse the operation. Okay, all right, so if that is the case, then we can move on to the general discussion of how are we going to derive the post condition of an assignment statement from its precondition. So there are several steps here. Step 1, okay, so we'll go ahead and look at a hypothetical statement. We'll say that this statement is on line n. The variable on the left-hand side, I'll just leave it the same as LHS, which stands for left-hand side. And then the assignment, the right-hand side of the assignment is simply called RHS. In other words, these are all placeholders. N is a placeholder for an actual line number. LHS is a placeholder for an actual variable. And RHS is the placeholder of the expression on the right-hand side of an actual assignment statement. Are we doing okay so far with the concept of a placeholder? Because what I want to do is I want to give you the template where you can just plug in the actual content of an assignment statement, and then you can decide what to do in order to derive the post condition of the assignment statement from its precondition, from its own precondition. That's what we want to do, so that we don't have to kind of think about things, on an individual basis. We just say apply these rules step by step, and you can get to the post condition from the precondition. So step 1 is really just a simple step. It says define f of LHS to its RHS. It's just a definition. Just so that later on we can refer to function f and potentially the inverse function of that of that function. Are we doing okay so far? Step one is just taking the content of that particular statement, of the assignment statement, and define a function out of it. Okay, it's just notation. Step two is to use that notation and determine whether function f has an inverse or not. If so, what is it? So we want to find an inverse of function f according to this definition. You use the right-hand side of the assignment statement as the definition of function f. Okay. So now, obviously, this is a Boolean kind of thing. Either yes, I can find an inverse function, or no, I cannot find an inverse function. So that's why step 3 has two alternatives. 3a is basically saying if there is an inverse function, I'll just say apply the substitution operation. I'll define what the substitution operation is later. Step 3b is the else case. It's basically saying if there is no inverse function, then we apply the what I would call the forget operation. Okay. Are we still doing okay so far with these steps? Step 1 is just looking at the assignment statement, pick out components out of it to define your function f. Step 2 is a little bit more tricky. We want to find the inverse function according to the definition of step 1. Depending on whether there is an inverse function or not, you either go for 3a if there's an inverse function, or you go for 3b if there's no inverse function. So are these steps okay so far? I will define what is a substitution and what is a forget operation next. Okay. All right. So in case you want to go for step 3a, then we'll define step 3a1, which is the next step that you have to perform. Step 3a1 is going to work like this. The post condition of line n is the substitution applied to the precondition of line n. Whenever you see the variable of the left-hand side appears, replace it with f prime, our inverse function, applied to LHS, the variable on the left-hand side of the assignment statement. Step 3b1 is saying the post condition of line n is applying the forget operation on the precondition of line n. You basically look for all occurrences of the LHS or the left-hand side variable. Any comparison that has the left-hand side variable has to be, you have to get rid of all of those. After the forget operation, you can add one more thing, because what you can add in this case is the left-hand side variable equals to the expression on the right-hand side, because that's the effect of an assignment statement. Are these steps okay so far? I'm going to give you the exact details of what to do with sub and forget.
Can you explain 3A1 again?
3A1 is saying, okay, in 3A1 we are already given, or in some previous steps we have already derived the precondition of line n of this particular algorithm. So we start with that. Inside pre-n, or the precondition of line n, we look for all occurrences of the variable on the left-hand side of the assignment statement. For each case, for each occurrence, we replace it with f prime, which is the inverse function applied to the variable. I'll give you a concrete example. So are these steps okay so far? I will give you a concrete example later on. I just want to make sure that the flow of these steps are okay so far. Is that okay? All right. So let's move on and use an actual concrete example. I'll use at least 2 to illustrate these rules. Okay. So we say concrete example 1. In the previous class, I was kidding with my class. Is it concrete with rebar or not? And now I know you cannot use a rebar unless you have enough thickness in the concrete, because the rebar is supposed to have 2 inches of concrete below and 2 inches of concrete above. That's the code of pouring concrete. Don't ask why I know that now. Do I look like that I just poured concrete yesterday? No, because I'm still standing with my back straight, right? All right, so let's look at this particular example. Let's look at line 67, hypothetical line, and the statement says y gets y times 2. Okay, that's the assignment statement. So when you apply these operations, step 1, STEP, step 1 is just defining the function. So we are defining f of y to be the right-hand side, which is y times 2. Or if you prefer, since some of you are math inclined, we can just say 2y, same thing. Are we okay with step 1? Step 1 is really just identifying components in the assignment statement so that we can define our function. Is that okay? Okay. Step 2 is to say, well, if f of y is defined to be 2y, is there an inverse function to this f of y? Well, what do you think?
Yeah.
Okay, an inverse function doesn't exist. Okay, an inverse function exists. F prime of y is y over 2, 0.5 times y, whichever way you want to express it. So we'll just say it is y divided by 2. Okay. And if you want to, this step is optional. You can say f prime applied to f applied to y is f prime applied to 2y. But since f prime is just dividing whatever is in the parentheses by 2, this whole thing becomes 2y divided by 2. And by simplification, you can now get back to y. So that's just a simple proof that f prime is in fact the inverse of f. Okay. So after step 2, what would be my next step? Because the next step I have to choose. I have to choose either 3a or 3b.
3a.
We have to choose 3a in this case because an inverse function does exist. All right, so we go for step 3a. In step 3a, we apply the substitution operation. Okay, so you just have to use the substitution operation. And now we move on to 3a1, which is just the next step. The next step is to express the post condition of line 67, because our n is actually 67 in this case. That's the line number. It is the result of the substitution applied to the precondition of the same line, which is line 67. We locate all occurrences of the variable on the left-hand side, which variable are we talking about here?
Y.
The one y itself. Yep. We look for all the y's and replace each and every single one of those with f prime applied to y. That's the first step. The second step is to expand what exactly is the precondition of line 67. Well, I haven't really quite given you that fact already, so let's go back and present that one here. So for whatever reason, we'll just say that the precondition of line 67 is the following. We can just say that y at this point, don't ask me why, because it has to do with the 66 lines before this line, but at this point I know that y is greater than 7 times z, and y does not equal to x. Okay, that's all that I know at this point as a precondition of line 67. So what do we do with this? In the substitution operation, we just expand it. Okay, we first expand what is pre-67, what we substitute the actual precondition of line 67 into this place. Y should still be specified because we are looking for occurrences of y. But what exactly is f prime applied to y? It's y divided by 2. Okay, so now we are ready to actually do the substitution. The substitution operation, as the name implies, is really just going through the precondition, which is this part here. Every time we see variable y, we replace it with the expression y divided by 2. That's all it's going to do. So in this case, I'm just going to do it this way. In other words, I'm going to copy and paste the expression, and then I'll go through the entire thing and just replace each and every single one gradually. So I see y here, and I should replace it with y divided by 2. I see y here, I replace it with y divided by 2. That's it. I know some of you are really tempted to do the simplification, like in the first condition, you can say y is greater than 14 times z. Okay, that's one simplification, because you can multiply both sides by 2. In the second one, it's kind of like a toss-up. You can say y is different from 2x, or you can just keep it the same way as it is, which is y divided by 2 is different from x. Is that okay so far? Those are very mechanical steps, right? The only part that is not mechanical is step 2. Step 2 does require you to try to figure out what is the inverse function of something. But why does it work? Why do you think the substitution operation works just like this? Why do you think the inverse function is important in this case? What does it allow us to do?
It undoes the action that line 67 performs.
Yep, it basically is an undo, right? It's undoing what line 67 is doing. So in post 67, whenever we refer to y, we are referring to the value of y right after line 67 has done its job. Okay? But when you apply f prime to y, you're reversing the new value of y back to the old value of y. Is that making any sense? So if you know how to reverse the value of y back to its old value, then you can keep all the relationship of y with respect to all of the other variables. That is why it works. So let me just explain that one more time. In pre-67, whenever we see the value of y here, and also the value of y here, these are referring to the value of y right before line 67 happens, okay? Right before it happens. When you look at the post condition, this y refers to the value of y right after line 67 takes place, and same with this particular value. So we have the old value of y and the new value of y. What the inverse function f prime allows you to do is this expression, which is f prime applied to the new value of y, is a way to reverse back to the old value of y before line 67 happens. Is that working out okay? The rationale of the substitution rule. Okay, any questions about this step? Yep.
Are we supposed to know how to inverse these functions?
Yeah, well, we're going to use mostly just increment, decrement, divide by 2, multiply by 2, that sort of thing. So I think it's not an unfair assumption that we can reverse those operations. What if it is a multi-step operation? I'm just throwing this out so that you guys can get an idea of how to do it when it's not a simple expression. So what if I define f of x to be 2x plus 1? Okay. Then what is f prime or f the inverse function in this case? Now we know one thing. Okay, we know two things actually. We know that it involves subtracting 1. We know it involves dividing by 2. Because to reverse the negative, add 1 here, we have to subtract 1. To reverse the 2x, we have to use divided by 2. The question is the order of operation. What do you do to reverse this operation? Well, you have to reverse the last operation first. Okay? So you have to reverse the plus 1 first. The plus 1 is the last operation of 2x plus 1. So the first thing you do is to reverse the plus 1, and then you reverse the other operation. In this case, it's reversing 2x. So dividing by 2 is the last operation of the inverse. Are we doing okay so far? Now you can ask your math professor why that is the case. It has to do with a property like this. If you can express a new function, h here, if you can express, I'm not going to use the full math notation here, so I'm going to make it like, if h of x is defined to be g applied to f to x, then the inverse function of h is going to be the inverse function of f applied to the inverse function of g applied to x. Okay, which is basically stating the same thing. You know, the last thing you do is the first thing you undo. It's just like when you apply changes to a document. Okay, when you do the undo, when you press undo or Control Z in a Word document, is it undoing the very first thing that you do, you know, when you open up the document, or is it reversing the last operation that you perform? Same thing. Okay, so intuitively it makes sense as well. Are we doing okay so far? So this technique will allow you to reverse an expression that is not really simple. Are we doing okay so far? Right? If we are doing okay so far, let's go ahead and look at another example. So we have to look at concrete example 2. In our example 2, let's say this is on line 12. Okay. So on line 12, we have this particular statement: z gets 5. Okay, that's all it's going to do. The precondition of line 12 is the following. It says, you know, z is greater than x, and x is less than y, and I think that's probably okay. So we'll just, you know, use this as a precondition. So we apply the steps again. Step 1 is to define the function itself. So this time we're defining f of z is 5. Are there any questions about step 1? Step 1 is all about taking the statement itself into different parts, the right-hand side and the left-hand side, and then define our function accordingly. So now we can just refer to function f, is there a reverse or not? In step 2, we determine whether there's an inverse function or not. Well, since f of z is mapping everything to 5, just like in this example here, it doesn't have an inverse. There's no way to start with a value of 5 and find out how we got there, because, you know, it could have come from any value on the left-hand side. So now we can just conclude that there is no inverse function for f. Well, according to our steps, step 3b says if there is no inverse function, then we have to use the forget operation. And then in step 3b1, we say the post condition of line 12 in this case is the result of forgetting something, potentially forgetting something in the precondition of line 12. Anything that mentions z, we have to forget. But after we forget everything that we knew about z, there's one new thing that we know about z that has to be true at this point. Z must be 5 at this point, because the assignment statement changes z to 5. Are we, yep, go ahead.
Pre-12 was given and not derived?
It is given in this case.
Okay.
In most cases, pre-12 is derived from line 11. So we can chain, you know, these pre and post conditions one by one. So in this case, you know, without showing, you know, the other 11 lines, I'm just saying that for whatever reason, pre-12 is, you know, stated as follows. Are we doing okay so far? Okay. And at this point, I'm going to pass the roll sheet. All right. So how do we do the forget operation? Well, the first thing we do with the forget operation is kind of the first thing that we do with the substitution operation. We take a look at pre-12, and then we just, you know, put it here. And then we say, well, if there's any comparison involving, you know, z, we don't want to keep it, because it is no longer guaranteed. So we have to get rid of the first one. You know, z is greater than x is something that we are going to forget. But this one we can keep because it doesn't mention z at all. And then on top of that, we also now know that z equals to 5. That's it. That's the application of the forget rule. You can also, some people can probably look at this and say, but sometimes we're going to forget more than what we really need to, because what if z equals 5 is actually a part of the precondition? Well, since we're in this class, we're doing things very mechanically, we'll just apply this and say, okay, we're going to forget it, and then we'll add it back. Okay. But in reality, when you actually try to prove the correctness of an algorithm, we cannot just be mechanically doing this, especially when we use the forget operation. Great. Any questions? If there are no questions, let's go ahead and see if we can chain these things with an algorithm that has two lines. So line 1 is x gets k, and then line 2 is y gets x gets x plus 2. And I'll make the precondition of line 1 to be not just true. I can make it a little bit more fancy in this case. Let's say the only thing I know is k is greater than 0. Okay, that's all. But I don't know anything about x. Okay. So now we have to. I'm going to do my own homework assignment. Now, in your homework assignment, you don't have to really go through step 1, step 3, step 3b, step 3b1, but you do have to indicate all of those things. Okay, so you can kind of roll a few steps into one, but I'm still looking for the rationale of why do you choose to use the substitution operation, or why do you choose to use the forget operation. But you can kind of combine, all those things, into like 1 or 2 statements instead of really spelling it out like that. Okay, so I'm going to give you an example of what I would do if I were to do this homework assignment. So I would say, for line 1, okay, I would say the right-hand side of line 1 does not refer to the left-hand side. In other words, if you look at k as an expression, it does not involve x at all. So that's what I mean when I say the right-hand side of line 1 does not refer to the left-hand side, the variable on the left-hand side. As a result, there's no inverse function. Use the forget operation. Okay, so that would suffice to take the place of step 1 all the way up to step 3b. Are there any questions about the kind of abbreviated form of what I expect from your answers? Okay. So now I can just apply the forget operation. So that means the post condition of line 1 is applying the forget operation to the precondition of line 1. Every time we see the variable on the left-hand side, which is x, we have to forget that expression. But on top of this, we also know that x equals to k at this point. The next step is to expand what is pre1. Pre1 is just k is greater than 0 in this case. Does k is greater than 0 mention anything about x? Nope. So do we have to forget it? We can keep it. Yep. Okay. So we keep k is greater than 0, and then on top of that, we also want to say that x is equal to k at this point. Are there any questions about post 1? How I derived post 1 from pre 1? No questions? Okay. So knowing this is post 1, this is the tricky step. How do we get to pre 2? How do we chain these statements? Well, it's easy. Pre 2 equals to post 1 because lines 1 and 2 are sequential. Or the statements of line 1 and the statement of line 2 are sequential to each other. Now, this is not something that is naturally following, because if line 1 is the beginning of a conditional statement, then line 2 is not exactly sequential to it. Because in that case, I actually have a choice to either go for line 2 or the first line of the else branch. But in this case, I don't have a choice, right? Since I don't have a choice, the precondition of line 2 has to be the post condition of line 1. So that's why I can make the link here to say that pre 2 equals to post 1. You don't have to repeat the entire thing. You just have to say that they are the same. And then then we have to go through the analysis again. So in this case, we are looking at line 2 at this point. Okay, on line 2, f of x in this case is x plus 2. F prime of x is x minus 2. So we have to use the substitution operation. So I just abbreviated all the steps from step 1 to step 3a into one single statement. All I have to know in this case to grade your homework assignment is what is the function? Is there an inverse function? And which operation are we going to use in this case? That's all I need to know. 3 things. Are we doing okay so far with line 2? Why we ended up choosing to use the substitution operation? Okay. So now that we know we are supposed to use the substitution operation, we apply the template of a substitution operation first. Pos2 is the result of applying the substitution operation on the precondition of line 2, which is what we are given with. Every time we see the occurrence of the left-hand side variable, which is x in this case, we want to replace it with f prime, the inverse function, applied to x. So you have to make sure that you include this step here, because this is really the template of applying the substitution operation. And then after this, we can expand what is pre-2. Pre-2 is the same as post-1, and post-1 is already derived here, so we can just copy and paste it here. And what is f prime applied to x? F prime applied to x, which is the inverse function of x, is just x minus 2. So we go ahead and expand it here as well. And the rest is really just going through the expression one by one, one variable at a time, and change all the x to x minus 2. We'll do the scan from left to right. K is not x. We have one x here. Replace it with x minus 2, and we're all done. Fairly mechanical, and no need to do any simplification if you don't want to. So are we still doing okay so far with this code? Go ahead. Question?
I was just thinking, if we wanted to be concise about the way we did it on our homework, could we do the step 1, step 2, step 3, and write that all out? Would that be okay?
Yeah, that would be fine. Yeah. I'm just giving you the simplest thing, or the minimum of what I'm looking for. Yeah. So if you want to be kind of more verbose, definitely go for that. Yeah. So, are you guys confident that you can get the homework assignment done? Let me just kind of switch back to the homework assignment so you can see the kind of statements that you get in the homework assignment. So the homework assignment looks like this. We have y gets k, x gets y plus j, x gets x times 2, y gets y plus 1, in that particular order. The real key is, can you determine, one, is there an inverse function of the right-hand side in each case? And if there is one, do you know how to find the inverse function? And I think the examples that we went through today cover all the inverse functions that are applicable in this case. I didn't use anything tricky like log or exponent.
So do we start at 1 and work our way down, or we start at 4 and work our way backwards?
No, you start with 1 because I give you pre-1 to start with, so you have to start with pre-1. Yeah. I know why you asked the question, because last time I gave you the end result and we went backwards to find out what happened. Yep.
Is it okay to simplify on the homework?
Yes, but you do have to show me the steps of the derivation, but you can simplify, afterwards. Because the way I grade this type of homework assignment is not I look at post 4 and if it's right I give you the full credit. I actually give you credit for the steps in between and whether you demonstrate to me why you choose a particular step and how the step itself occurred. So the steps are the components that are actually worth the points and not really as much as the final product, the final result. Yep.
For number 2, would that be a inverse? You can't do.
Okay, let me ask you this question and you can answer that on your own. Okay, does the right-hand side of line 2 refer to the left-hand side? Because in order for a function to be reversible, the expression of the function has to have the variable itself.
Okay.
Okay. Yep. So are there any other questions about this one? No questions?
It's in you.
It's due in a week, so you have a week to do this. My suggestion is to start on this as early as possible, work on it over the weekend. So this way, if there are any questions, you can bring those questions on Tuesday next week, and we'll still have time to, finish those questions. And since we are now, talking about pre and post conditions, it also means that we can have our first exam 1 week after next Thursday. So 2 weeks from now, we'll have our exam 1. Yep.
Are you gonna give us like examples to do?
Oh yeah. Next Thursday, I will go over the answer of this one, but I'll also at the same time give you sample questions from previous semesters.
Okay.
So those are not exactly just exercise questions that are simplified. They are actual questions from past semesters. And those of you, if you watch YouTube, you can actually locate my lectures from past semesters too. Yep. All right. Now the exam, I just want to kind of go over the exam itself a little bit. It's going to be in the classroom, during our usual lecture time for the entire duration. So we'll go from 10:30 to 11:50. So we have 80 minutes to complete the entire exam. I will start to pass the exam paper right on time, usually maybe a minute early or so that way the last person in the class, can get the exam right on time to start at 10:30. I will collect the exam at 11:50. Okay, so people who are still writing, I will just kind of grab the paper. I've yet to have to do that, but sometimes I have to kind of, nudge people and say, okay, it's time to turn it in. It is open book, open notes. Okay, you can bring anything that is printed or handwritten prior to the test to help you in the exam. Okay, now I have to make it very clear, it has to be either printed or handwritten prior to the exam. In other words, if someone is to write down a note, and say, okay, I'm going to pass it to my neighbor, because, hey, notes are allowed, right? But so I just wrote a note and passed it to my next door neighbor. That would not be allowed. Okay, it has to be written or printed prior to the test. It also means that you guys can study together. Okay, study together, come up with your quote-unquote cheat sheet. It's not exactly a cheat sheet because you are allowed to bring anything that is printed or handwritten to the test, but it helps to summarize all the concepts that we have talked about so far and condense all that material into 1 or 2 pages that you can locate information quickly.
Are we gonna have to do like tomes?
Sorry?
Tomes. Are the tomes on the midterm? Like vocab?
Terms?
Yeah,
Terms.
Like the
The definitions?
Yeah, words.
No, it's going to be mostly traces and
Okay.
1 question on pre-post conditions.
Okay.
Yep.
Is there going to be anything we didn't do in homework on the test?
It'll be all of the topics that we have talked about, on homework. The only topic that I won't really ask any questions about would be, what is a developer, or the testers, software system analysts, and so on. So those concepts I'm not going to ask any questions about. So it'll be all about traces and pre and post conditions. Yep, go ahead.
You said there can only be an inverse if it contains the letter itself, too, on the right hand side.
If the right-hand side does not refer to the left-hand side or does not have any references to the variable of the left-hand side, it cannot possibly be reversible.
Okay.
Now, even if there is a reference, it can still be not reversible. I'll give you one example. Okay, f of x equals to x minus x has no inverse, right? So even though the right-hand side or the function itself seems to mention x, but it has no inverse because x minus x reduces to a constant of 0. Okay, so anytime you map all the values to a single value, there's no inverse. There's another one that is a little bit tricky. If f of x is x times x, also technically has no inverse. From the mathematical point of view, it has no inverse. Why is that the case?
x divided by x is 1.
Because it can either be positive x or negative x. In other words, if I tell you that x squared is, let's say, 64, and I want to know what x is in order to make x squared 64, there are two answers, not one. Because x is 8 or x is negative 8 in that case. So technically speaking, there's no inverse. But in the context of our pre and post conditions, even though there's no inverse, you can still state that. You can still state, x equals this or x equals that when you work it into your pre and post condition. But it's no longer a very simple substitution. So I'm not gonna. I won't give you tricky cases
So
like
it
that.
just reduces the disjunction into the.
Yeah, you kind of have to expand it, because you have to separate a single comparison into two, and then use a disjunction to join the two. So it gets a little bit more involved, when you have trickier cases like that. Okay. Yep.
Would that be the same case for x plus x and x divided by x, if those are constants?
One is and one is not. X plus x is not a constant, but x divided by x is. Yep. Any other questions related to the homework assignment? No questions? Okay, so this almost concludes everything that we need to talk about with pre and post conditions. Did we go through one case where we have to walk backwards with a conditional statement? We did? I think we did.
Yeah.
Yep. Okay, so what we'll do is I'm going to talk about the concept that will be your next homework assignment, but it's not going to be in the test. Okay, so I just because we still have 5 more minutes, so might as well just go ahead and do it. So this one has to do with how do we deal with conditional statements. So we'll go ahead and use, once again, hypothetical line numbers. So line n is the beginning of the conditional statement. We'll say if C, which is a hypothetical condition itself, okay, then we have a block here. The next line is always n plus 1, so I can just use n plus 1 here. And we'll just say this is block 1. We don't care what block 1 is. It can be a single statement, it can be no statement, it can be a whole bunch of statements. We don't know what it is, we don't really care. And then we have m here. M is else, n plus 1 is our block 2. And then we have our, let's make it k here. And k is the end of the entire thing, and if, okay. So the last line here is, this line is k minus 1. And this line here is m minus 1. Okay, is that okay so far? I'm just trying to make labels for those specific lines so that I can refer to those lines. All right, so the first thing we want to do is to say, okay, what is the precondition of line n plus 1, or the beginning of the then block? That will be the precondition of line n and the condition C itself. Is that making any sense? If I'm about to execute line n plus 1, which is marking the beginning of the then branch, that means the condition of the conditional statement has to be true, and also at the same time, the precondition of the entire conditional statement also has to be true, because I have not had a chance to change anything at that point. The derivation of this entire block, I cannot say anything about it because it depends on the actual statements in block 1. The precondition of m plus 1, which is the line right after the else, is kind of the same thing. The precondition of the entire conditional statement still has to be true. But C cannot be true because I am just about to start with the else branch. Is that okay? All right. So at some point I'm going to have, post m minus 1 is derived on a case-by-case basis, because it all depends on what is in block 1. And for the same reason, post k minus 1 is also derived on a case-by-case basis. But one thing I can also at least conclude is post k, the post condition of the entire conditional statement, is just a disjunction of post m minus 1 and post k minus 1. So that really is the template of a conditional statement. without even knowing what is the condition itself, or what is in block 1 and what is in block 2. What if the conditional statement has no else? Then it's equivalent of having an empty block 2. Now, if you have an empty block 2, that means post k minus 1 is the same as pre n plus 1. So that's because it's just a straight through. So are we doing okay so far with that template? Because this is what we do. This is what I try to do, is to try to make it so that everything is just rule based, template based. When you see a conditional statement, you have to identify what is the condition C, what is block 1, what is block 2, what are the line numbers corresponding to n, n plus 1, n minus 1, and so on. And then you can use this template to help you structure your pre and post condition derivation. What if there's a conditional statement inside this conditional statement? Well, you apply the template again to the conditional statement that is included, right? What if in the conditional statement we have a sequence of assignment statements? Then you apply what we already know about conditional statements, so that you can go from the precondition of the first assignment statement to the post condition of the last one. Then you have the derivation of that one single block of code. The only thing I won't ask you to do is loops, okay? Because those are just kind of difficult to deal with, at least at this point. In reality, there are ways to avoid dealing with loops altogether. It's really too early to talk about that concept, but I can kind of mention the name. It's called recursion. How many people have heard of the name recursion? Okay, and in what context have you encountered that name? Star Trek?
No, no, it's part of moving, right? Like driving your axle.
Okay. Did you encounter the concept in conjunction with a proof technique called proof by induction? More or less, no?
Yeah,
Okay. Yeah, if you heard of this term recursion from Star Trek, The Next Generation, I can tell you right away they used it in an incorrect way. They combined recursion with positronic ring and Lieutenant Data, which makes absolutely no sense whatsoever. But we will deal with recursion in this class, okay? Most people think it's a very advanced concept, but I can assure you that it is not, okay? So by the time we get there, we'll get there.
Can
All
I
right.
get the 9 a.m. 9 a.m. roster?
Oh, right. Just hold on a second.
Here,
This is
convenient
9
for
a.m.
sitting in places.
Yep. If there's an X already, just kind of cross out that X and write your name.
I was trying to look for YouTube videos on Moodle.
Uh-huh.
I can't find it.
Okay.